Today, I want to talk about avoiding primitive obsession. What is primitive obsession? It is when code relies too much on primitive data types. Let's consider this example where we pass name and email address as a string. So in this scenario, as far as the compiler goes, they're both the same. You can, if you swap the parameters, it'll work fine as from a compiler point of view. So how can we actually fix this, right? So if we take this example where name is a string and email is a string, logically speaking, this is not true. Name is a subset of string. Similarly, email address is also a subset of a string. For example, is an empty string a valid name? It's not. So maybe there should be a type called name where you have a length check and maybe random characters are not allowed in the name. Whatever the business rules may be, that should be part of the custom type for name. And similarly, email address has got its own rules. Because if we go with this code as is, then the string that is being passed around, you don't know if it is valid. So let's introduce the custom types. So with the custom types, we have name and email address. So name can have its own check, like minimum string length, maybe don't allow random characters and so on. Email address all similarly have its own set of rules on what makes a valid email address. Now, when these types are created, you have run your validations, and if you keep it immutable, like domain-driven design, value objects are not mutable. So if you follow that pattern, then you don't need to check for these again within your code. Once you have this type passing around, you know it is valid, and the compiler has done its work. If by mistake if you swap the parameters, try to pass the name for email as an email parameter and vice versa, the compiler will be able to flag you. And in a big project, these things are a nice blessing. So let's look at an example of avoiding primitive obsession. In this example, to create a user, we need to pass in first name, last name, email, and a password. Now, I have avoided primitive obsession by giving a strongly typed called first name and last name. Now, it is possible all of this could have been strings. If it was strings, then the problem is that when someone calls this particular API, they could reverse the order, right? What if they pass email first or last name first? The compiler will not be able to give you any kind of error. So having strongly typed classes like these help with it, and it's also not that hard to do. If we take an example of first name or last name, basically it's you have a class that is just derived from a string type, and similarly last name is a string type, and so on. So you just this few of these types that I've declared, and then I'm using it in the user class. When this API is called, the compiler can now give you a check. So here we have register API method, and we are calling it with this particular DT object where everything is primitive, since what's on the wire has to be primitive. But the first thing I'm doing is converting it all to a value object domain types. And then I call this create user. So here first name, last name, and all are strongly typed. If I move this to the wrong position, we're going to get a compiler error saying that it cannot convert last name to first name. So this is the beauty of having avoiding primitive obsession, and also makes the code a lot clearer. So instead of just saying string, 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 or int, int, int everywhere, you can actually call out what it is, right? Maybe it's money, whatever those things stand for. Gives more meaning to the code, makes it easier to read. Thank you. You can look out the sample at my link on GitHub and clone it, and you can try out the samples and play around with it. Take care. Bye.